Hello dear students, welcome back to the second PUC online classes. In the last class already I discussed about the concept of principle of superposition from using Coulomb's law or the force between the multiple charges. In this class I am going to start the next subtopic in the first unit, that is electric field. What is field? The region around the body. Suppose if I consider this is the earth and this is another body. This body is attracted towards the surface of the earth, or the object is falls on the surface of the earth. This object is falls on the surface of the earth. This is because of the gravitational field is present around the earth. The region around the earth where the gravitational force is acting on this body, that is called gravitational field. Like this, now I consider these are the two magnets. It has a two poles, one is north pole and another one is south pole. The north and south pole of the magnets are attracted towards each other like charges are repel each other, unlike charges are attract each other. Like that, here also the like poles are repel each other and unlike poles are attract each other. Here the magnets are attracted due to the magnetic field. This is because of magnetic field. Here the magnetic field is formed around the magnet, and in this region, in the first case here in this region, the gravitational field is formed. In this region, the magnetic field is formed. Like that, the electric field means here electric field is the space property. Field means kshetra anta ನಾವು ಕರಿತೀವಿ ಕನ್ನಡದಲ್ಲಿ. It is the space property. Here electric field means, now I consider these are the two like charges. When we consider the two like charges, they are repel with each other. In the second case, one is positive charge and another one is negative charge. Now these two charges are attract with each other. This is because of electric field. The region around the electric charge is called electric field. When we consider two like charges, they are repel each other. When we consider one is like charge and another one is unlike charge, or one is positive and another one is negative, the positive and negative charges are attracted with each other, and two like charges are repel each other and unlike charges are attract each other. It is a simple property of the electric charge, but this is because of electric field. ಇದು ಯಾಕೆ ಈ ರೀತಿ ಆಗುತ್ತಾ? This is because of electric field. ಯಾರೋ ಸ್ಟೂಡೆಂಟ್ ಕ್ವಶನ್ ಕೇಳಿದ್ರು ಒಂದು, ಸರ್ ಯಾಕೆ ಈ ರೀತಿ ಆಗುತ್ತೆ? ಬಿಕಾಸ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್. This is because of electric field is formed around an electric charge. The electric charge, the region around the electric charge is called electric field. Due to that electric field, it is repel with each other or attract with each other. Here, now I consider this is a unit positive charge. Here, the space around the charged body in which the influence of the charge can be felt. The space around the charged body which influence of charge can be felt, then it is called electric field anta ಹೇಳ್ತೀನಿ. The space around the charge. Now I consider this is the positive charge plus Q. The space around the charge in which its presence is experienced, that is called electric field. That is called an electric field. To test the presence of this electric field, to test the presence of this electric field. Electric field means the space around a charge in which its presence is experienced, or space around the charge in which test charge experience an electric force, then it is called electric field. To measure the presence of electric field, now I place a small test charge to measure the electric field in this region. Here, when the positive charge, now I consider this is the plus Q. The region around this electric charge is called electric field. The region around this electric charge is called electric field. Here, To check the presence of electric field around this electric charge, now I place a test charge Q0 plus Q0, test charge. Test charge means an electric charge of small magnitude. This is called test charge. Test charge means an electric charge of small magnitude whose presence does not affect a already existing electric field. Whose presence does not affect a already existing electric field. Then it is called a test charge. To check the presence of electric field in this region, we use a small test charge, an electric charge of small magnitudes whose presence does not affect the electric field or already existing electric field, then it is called test charge, or the charge which detect the effect of the source charge. Here this is called the source charge. This is called a source charge. Source charge means the charge which produces an electric field. The charge which produces an electric field, then it is called source charge. This is also source charge. A charge which produces an electric field, then it is called source charge. To check the presence of electric field around the source charge, now we place a small test charge. Test charge means it is a small charge. It's having a small magnitude whose presence does not affect a already existing electric field, then it is called test charge. Clear? Source charge means a charge which produces an electric field, then it is called source charge. ಯಾವ ಚಾರ್ಜು ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಅನ್ನು ಪ್ರೊಡ್ಯೂಸ್ ಮಾಡುತ್ತೋ, ದ ರೀಸನ್ ಅರೌಂಡ್ ದ ಎಲೆಕ್ಟ್ರಿಕ್ ಚಾರ್ಜ್, then it is called electric field. The charge which produces an electric field, then it is called source charge. Test charge means an electric charge of small magnitude whose presence does not affect a already existing electric field, then it is called a test charge, or it is also defined as the charge which detects the effect of the source. A charge which detects the effect of source charge, then it is called test charge. The best example for this test charge is that is unit positive charge anta ಹೇಳ್ತೀವಿ ನಾವು. Unit positive charge. It is a 1 coulomb of charge, or it is a unit positive charge. The region around the electric charge is called electric field, or space around a charge in which its presence is experienced, then it is called electric field. Source charge means a charge which produces an electric field. Test charge means a charge of a small magnitude whose presence does not affect the already existing electric field is called a test charge. Now we will move to the types of electric field. Here the electric field can be divided into 3 types: uniform electric field, non-uniform electric field, and radial electric field. ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಅಂತ ನಾವು ಯಾವುದಕ್ಕೆ ಕರಿತೀವಿ, ಇದನ್ನ ಕ್ಲಿಯರ್ ಆಗಿ ನೀವು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಮಾಡ್ಕೋಬೇಕು. ನಾವು ಐ ಕನ್ಸಿಡರ್ ದಿಸ್ ಇಸ್ ದ ಪ್ಲಸ್ ಕ್ಯೂ, ದಿಸ್ ಇಸ್ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್. ವೆನ್ ದ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ is placed at point A, the region around the electric charge is called electric field. The region around the electric charge is called electric field. If the distance is increases, the electric field is decreases. If the distance is increases, electric field is decreases. The region around this electric charge is called electric field. To check the presence of this electric field, now I place a small test charge. Test charge means an electric charge which is having a small magnitude, and this test charge does not affect a already existing electric field in this region. But here, this electric field can be divided into 3 types. The electric field can be divided into 3 types. First one is uniform electric field, and the second one is non-uniform electric field, and the third one is radial electric field. First one is uniform electric field, second one non-uniform electric field, and third one is radial electric field. Now we will see one by one. That is the uniform electric field. The electric fields are classified as first one uniform electric field, second one non-uniform electric field, and the third one radial electric field. The uniform electric field, the word itself says the electric field is equally distributed The electric field is equally distributed, or the electric field is same at all the points in that field, then it is called uniform electric field. ಅದಕ್ಕೆ ನಾವೇನಂತ ಕರಿತೀವಿ ಯೂನಿಫಾರ್ಮ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್. Or if a test charge experience the same force at all the points. Here now I consider this is the plus q and the region around this electric charge. The region around this electric charge is called electric field, and plus q naught, it is a test charge. Here this test charge experience the same force. The test charge experience the same force at all the points in this field, then it is called uniform electric field. When the magnitude as well as direction of electric field or electric field strength or electric field intensity is same at all the points, then it is called uniform electric field. The word itself says the electric field is uniform in that space, then it is called uniform electric field. And electric field, it is a vector quantity. The uniform electric field lines are graphically represented by like this. Here this is the graphical representation of the uniform electric field lines. The uniform electric field lines are always moving in the straight path with equidistant and parallel with one another. These are the imaginary lines, electric field lines anta karitivi. Uniform electric field. Uniform electric field means if a test charge experience the same force at all the points in an electric field. Then this field is said to be uniform. The best example for this uniform electric field is the electric field between the two oppositely charged parallel metal plates, that is, they are separated by a small distance. The uniform electric field, the word itself says the electric field is same at all the points. Or electric intensity is same at all the points in the electric field, then it is called uniform electric field. This is the first case, uniform electric field. And the second type is that is non-uniform electric field. Here the word itself says non-uniform means the electric field intensity or electric intensity is different at different points in the field. The electric intensity or electric field strength is different at different points in the field, then it is called non-uniform electric field. And magnitude and direction of the electric field, here these are the different at different points. See that diagram. Here the magnitude and direction of the electric field intensity E, it is different at a different point. That's why the non-uniform electric field lines, they are curved in the path and they are not equidistant with each other. These types of electric field are called non-uniform electric field. This is non-uniform electric field. Or in this case, a test charge, it experiences different forces at different points in an electric field, then the field is said to be non-uniform. The field is said to be non-uniform. Uniform and non-uniform. This is non-uniform electric field. And the third one is radial electric field. The third one is radial electric field. Radial means here the field is always directed towards or away from the same fixed point. The field is always directed towards. Now I consider this is the plus q, positive charge. The field is always directed towards. The field is always directed towards the fixed point, or the field is always away from the fixed point. The field is always away from the fixed point, then it is called radial electric field. The field is always towards, or the field is always away from the fixed point or same fixed point, then it is called radial electric field. This is called radial electric field. See this diagram. Here the electric field is always directed outwards. This is called radial electric field. The field is always directed outward. These are the imaginary lines. In this case, the field is always directed outwards. This is called radial electric field. This is called radial electric field. Electric field means the region around the electric charge or space around an electric charge in which its presence is experienced with a certain force. Then it is called electric field. Electric field, it is a vector quantity. Source charge means a charge which produces an electric field is called source charge. Test charge means an electric charge of small magnitude whose presence does not affect a already existing electric field, then it is called test charge. And electric field, they are classified into three types: uniform electric field, non-uniform electric field, and radial electric field. Uniform electric field means the electric intensity is same at all the points in the field is called uniform electric field. The electric field intensity is different at different points in the field, then it is called non-uniform electric field. Radial electric field means the field is directed towards or away from the same fixed point, then it is called radial electric field. These are the types of electric field. Now we will see the electric field intensity or electric field strength. What is field intensity or what is electric field strength? Here electric field means the region around the electric charge is called electric strength or electric field ಅಂತ ಕರಿತೀವಿ. ಅಂದರೆ electric field intensity ಅಂತ ನಾವು ಯಾವುದಕ್ಕೆ ಕರಿತೀವಿ? Electric intensity, it is the measure of strength of an electric field. The region around the electric charge which is experienced with the force is called electric field ಅಂತ ಹೇಳ್ತೇವೆ. ಬಟ್ ಆ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಎಷ್ಟು ಸ್ಟ್ರೆಂತ್ ಐತಿ ಅದನ್ನ ನಾವು ಮೆಜರ್ ಮಾಡಬೇಕಾಗಿದೆ. ಒಂದು ಚಾರ್ಜನ್ನು ಒಂದು ಪಾಯಿಂಟಲ್ಲಿ ನೀವು ಫಿಕ್ಸ್ ಮಾಡಿದ್ರಿ ಅಂದರೆ ಅದು ಎಷ್ಟು ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡನ್ನು ಪ್ರೊಡ್ಯೂಸ್ ಮಾಡುತ್ತೆ ಅದನ್ನು ಮೆಜರ್ ಮಾಡ್ತಕ್ಕಂತಹ ಕಾನ್ಸೆಪ್ಟಿಗೆ ನಾವೇನಂತ ಕರಿತೀವಿ? ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಇಂಟೆನ್ಸಿಟಿ. ಕ್ಲಿಯರ್? ಒಂದು ಚಾರ್ಜ್ ಪಾಯಿಂಟನ್ನು ಅಥವಾ ಎಲೆಕ್ಟ್ರಿಕ್ ಚಾರ್ಜನ್ನು ಯಾವುದೇ ಒಂದು ಪಾಯಿಂಟಲ್ಲಿ ಇಟ್ಟಾಗ it produces an electric field around the electric charge. To measure that strength of an electric field, that is called electric intensity. Electric intensity is the measure of strength of an electric field. The electric intensity at a point in an electric field, it is defined as the force experienced by unit positive charge placed at that point. The force experienced by a unit positive charge placed at that point is called electric field intensity. Every charges forms an electric field around it. Every charges, a single small charge, elementary particle charge also, it produces the electric field around it. Therefore, here now I consider one unit positive charge, it produces the electric field. Here, electric intensity at any point in an electric field. The electric intensity at any point, electric intensity, it is the measurement of strength of an electric field. The measurement of strength of an electric field is called electric intensity. Remember that point. The measurement of strength of an electric field is called electric intensity. Electric intensity at any point in an electric field. The electric intensity at any point in an electric field, that is force acting on a unit positive charge placed at that point. The force acting on a unit positive charge placed at that point is called electric field intensity. Electric field intensity or electric field, it is mathematically denoted by the symbol vector E is equal to, here now I consider this is a source charge plus Q. If a test charge is placed at this point, test charge is placed at a point in an electric field, it experiences a force F. It experiences a force F. Then the electric field intensity E is equal to, that is F divided by, E is equal to F divided by Q naught. Q naught is a test charge whose magnitude is very small and whose presence does not affect a already existing electric field in that region, then it is called test charge. The force per unit test charge or the force acting on that point per unit positive charge, then it is called electric intensity. The electric intensity at a point in which the force experienced by a unit positive charge placed at that point is called electric intensity It is mathematically denoted by the symbol vector E is equal to F divided by Q naught, which is the expression for electric intensity. Electric intensity, it is the measure of strength of an electric field. Electric field ಎಷ್ಟು ಕ್ರಿಯೇಟ್ ಆಗೈತಿ ಅದನ್ನು ಮೆಜರ್ಮೆಂಟ್ ಮಾಡ್ತಕ್ಕಂಥ ಪ್ರೊಸೀಜರಿಗೆ ನಾವೇನಂತ ಕರಿತೀವಿ electric intensity. Electric intensity at any point in an electric field, that is force acting on a unit charge placed at that point. ನೀವು ಯಾವ ಪಾಯಿಂಟಲ್ಲಿ ಒಂದು ಯೂನಿಟ್ ಪಾಸಿಟಿವ್ ಚಾರ್ಜನ್ನು ಇಡ್ತೀರಿ ಅಲ್ಲಿ ಆಕ್ಟ್ ಆಗ್ತಕ್ಕಂಥ ಫೋರ್ಸ್ಗೆ ನಾವೇನಂತ ಕರಿತೀವಿ ಎಲೆಕ್ಟ್ರಿಕ್ ಇಂಟೆನ್ಸಿಟಿ. Electric intensity E is equal to F divided by Q naught. The force experienced by unit positive charge placed at that point, then it is called electric intensity. This is the vector form of electric field intensity. E is equal to F divided by Q naught. Here it is a vector quantity and SI unit is, the SI unit of force is Newton and the SI unit of charge is Coulomb. Newton per Coulomb is the SI unit of electric field intensity or volt per meter and the dimensions are already, you know the formula how to find the dimension, Newton per Coulomb, and for Newton it is m1 l1 and t to the 4 of minus 2 and for Coulomb it is I1 and t1. Therefore we get m1 l1 t to the 4 of minus 3 and I to the 4 of minus 1. Now you get this dimension formula already. All the dimension formula already all of you have studied in your first PUC topic, units and measurements. Okay, and what are the physical significance of electric field? ಇಲ್ಲಿ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ಗೆ ಇರತಕ್ಕಂತಹ ಫಿಸಿಕಲ್ ಸಿಗ್ನಿಫಿಕೆನ್ಸ್ ಏನು, ಯಾಕೆ ನಾವು ಇದನ್ನು ಸ್ಟಡಿ ಮಾಡಬೇಕು, ಫಿಸಿಕಲ್ ಸಿಗ್ನಿಫಿಕೆನ್ಸ್ ಏನದಾವು, ಇಟ್ ಇಸ್ ಅ ವೆಕ್ಟರ್ ಕ್ವಾಂಟಿಟಿ ಅಂತ ಹೇಳಿದ್ವಿ. ಬಟ್ ಬೈ ನೋವಿಂಗ್ ದಿಸ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಅಟ್ ಎನಿ ಪಾಯಿಂಟ್, ಹೌದಾ, ಇಲ್ಲಿ ಪ್ಲಸ್ ಕ್ಯೂ ಇಟ್ ಇಸ್ ದ ಸೋರ್ಸ್ ಚಾರ್ಜ್ ಅಂತ ಹೇಳ್ತೀರಿ. ಇಟ್ ಪ್ರೊಡ್ಯೂಸಸ್ ಆನ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್. Here to check the presence of electric field, now we place a test charge. This is called test charge and this is called source charge. Source charge means a charge which produces an electric field. Test charge means a charge which presence does not affect a already existing electric field, a charge which is used to check the presence of electric field in this region, then it is called test charge. By knowing the electric field at any point, the magnitude and the direction of the force experience any charge placed that point is to be calculated. It is the physical significance of electric field. ಎದಕ್ಕೆ ನಾವು ಯೂಸ್ ಮಾಡ್ತೀವಿ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡನ್ನು? ಬೈ ನೋವಿಂಗ್ ದ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ at any point, the magnitude and direction of the force experienced by any charge placed at that point can be calculated. This is the very important. What is the physical significance? It is used to calculate the magnitude and direction of the force experienced by any charge placed at that point can be calculated. ಈ ಪಾಯಿಂಟಲ್ಲಿ ನಾನು ಯಾವುದೇ ಒಂದು ಚಾರ್ಜ್ ಪಾಯಿಂಟ್ ಇಟ್ನಿ ಅಂತಂದರೆ ಇದ್ರದ್ದು ಮ್ಯಾಗ್ನಿಟ್ಯೂಡು ಮತ್ತು ಡೈರೆಕ್ಷನ್ ನಾನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಬೋದು. ಹೌದಾ, ಈ ಪಾಯಿಂಟಲ್ಲಿ ಇಟ್ಟಾಗ ಇದ್ರದ್ದು ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಆ್ಯಂಡ್ ಡೈರೆಕ್ಷನ್ನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಬೋದು, ಡೈರೆಕ್ಷನ್ ಆಫ್ ಫೋರ್ಸ್. ಈ ಪಾಯಿಂಟಲ್ಲಿ ಇಟ್ಟಾಗ ಇದ್ರದ್ದು ಕೂಡ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಆ್ಯಂಡ್ ಡೈರೆಕ್ಷನ್ ಆಫ್ ಫೋರ್ಸನ್ನು ನಾನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಬೋದು. ದಿಸ್ ಇಸ್ ದ ಮೇನ್ ಫಿಸಿಕಲ್ ಸಿಗ್ನಿಫಿಕೆನ್ಸ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್. ಬೈ ನೋವಿಂಗ್ ದ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ at any point, we get the magnitude and direction of the force experienced by the charge placed at that point. An electric field, it is a vector quantity. The SI unit of electric field is Newton per Coulomb or volt per meter, and this is the dimension formula. This is m1 l1 and t to the power of minus 3 and a to the power of minus 1. This is the dimension formula of the electric field. Here remember these 3 points clearly. The electric field is directed away from the positive charge. Now I consider here the plus q. In this point charge means a charge whose size is negligible as compared to its distance. Here the electric field E is always directed outwards from a positive charge. The electric field E is always directed outwards from the positive charge. Remember this point here. The electric field is always directed outwards from the positive charge. Now I consider this is the plus Q, this is the source charge. It produces an electric field. P is the point at which electric field is to be calculated. Due to this positive charge, the electric field is always directed outwards. Here the electric field due to this source charge, this is the source charge. Source charge means a charge which produces an electric field. The charge which produces an electric field is called source charge, but the E is always directed away from the positive charge. Illi positive charge ittu antandre electric field is always directed outwards. Illi suppose negative charge ittu antandre idr badli na negative charge anna consider madidni andre the electric field is always towards the negative charge. Here minus Q is the negative charge. Due to this negative charge also the electric field is produced, but the electric field is produced due to this negative charge is always directed here. E is directed towards the negative charge. The electric field is directed towards the negative charge. So the electric field is directed towards the negative charge. But here E is always directed away from the positive charge. Positive charge ittu andre electric field lines away move ಆಗ್ತಿರ್ತಾವೆ. Negative charge ittu andre electric field lines directed towards the negative charge like this. Here this is the plus Q and this is minus Q. Due to this positive charge the electric field lines are away from the positive charge. The electric field is away from the positive charge. Here due to the negative charge the electric field is towards the negative charge. The electric field is away the positive charge, electric field is towards the negative charge, and the direction of electric field due to the positive charge is always radially outward. The direction of electric field due to the positive charge, here this is called radial. This is called radial. The direction of electric field due to a point positive charge. Due to a point positive charge. Point positive charge or a point charge means a size of the charge particle is negligible as compared to its distance, then it is called point charge. The direction of electric field due to the point positive charge is always radially outward. The electric field is always directed away from a positive charge and directed towards the negative charge. Remember these 2 points very carefully. And the direction of electric field due to a point negative charge is radially inward and this is radially outward. Same process. Here the direction of electric field due to the negative point charge is radially inward and the direction of electric field due to the positive point charge is radially outwards. These are the basic terms related with the electric field. What is the main physical significance of electric field? From knowing the electric field at any point, the magnitude and direction of the force experienced by any charge that placed at every point that can be calculated, and it is a vector quantity. The electric field is always directed away from a positive charge. Electric field is always directed towards the negative charge. The direction of electric field due to the positive point charge is always radially outward. Due to the negative point charge is always radially inwards. These are the terms connected with the electric field. With this basic concept, now we will move to the next concept, that is the expression for electric field intensity due to a point charge. Expression for electric field intensity due to a point charge. Here, now I consider this is a point charge plus Q is the point charge. It produces the electric field. Here the positive charge, the E is always outwards due to the positive charge. E is always outwards or move away from the positive charge. E is the electric field or electric field strength. Expression for electric field intensity. Electric field intensity means the force experienced by a point charge or a force experienced placed at that point per unit positive charge, then it is called electric field intensity. Mathematically, you know the formula, vector E is equal to vector F divided by plus Q naught. Expression for electric field intensity due to a point charge. Here, now I consider a point charge plus Q at O. point charge plus q at O in an air or vacuum. Now let P be a point. P is the point at a distance r. P is the point at a distance r from the charge at which electric intensity is to be calculated. P is the point at which electric intensity is to be calculated. Electric intensity is the measure of a strength of the electric field. P point ಅಲ್ಲಿ electric field ಎಷ್ಟೈತಿ ಅದನ್ನ ನಾನು ಮೆಜರ್ ಮಾಡಬೇಕು. Electric intensity is a measure of strength of electric field at that point is called electric field intensity. P is the point at which electric intensity is to be calculated due to this positive charge at a distance r. Due to the positive charge, the E is always directed outwards. And to find the electric intensity at this point, how to find the electric intensity and how to check the presence of electric field? By making a test charge at this point. By place the test charge at this point. Test charge means a charge which presence does not affect the already existing electric field, and to check the presence of electric field in that reason here we use the test charge. Now applying the Coulomb's law for this equation, the electric force acting on this test charge, the electric force is acting on this test charge due to this positive charge. The electric force acting on this test charge here, this is called source charge and this is called test charge. Source charge means a charge which produces a electric field is called source charge. Test charge means a charge which is used to detect the presence of electric field in this region and it does not affect a already existing electric field, then it is called a test charge. The electrostatic force of attraction or repulsion between these two charges, the electric force acting on this test charge Q0 due to this positive charge, that is from Coulomb's law we know the equation F is equal to, in an air or vacuum, F equal to 1 by 4 pi epsilon naught Q1 into Q2 divided by R square. This is from Coulomb's law. But here now we will put the values 1 divided by 4 pi epsilon naught. Q1 is, that is plus Q, and Q2 is, that is Q0 plus Q0 plus Q and plus Q0 divided by R square. This is equation number 1. This is equation number 1 and it is acts along OP. It is acts along OP because due to the positive charge the electric field is always acted outwards. Acts along OP. You get this equation F. What is electric field intensity or how to define the electric field intensity? The electric field intensity or electric field strength, that is the force experienced by a unit positive charge placed at that point. Now I place the unit positive charge placed at this point. You get the force. The force experienced by a unit positive charge at this point. This is called electric field intensity or electric field strength. You get this equation force. But we know that the formula, the electric field intensity E is equal to vector F divided by plus Q0. Vector F divided by plus Q0. Substitute these two values here. Here this is the force. F equal to, value venide F equal to, that is 1 divided by 4 pi epsilon naught, right? Q into Q0 divided by R square F. Then plus Q plus Q0 divided by R square ಇದೆ ಇಲ್ಲಿ. F value ಅನ್ನು substitution ಮಾಡ್ರಿ, divided by ಏನಿದೆ value Q0, that is also plus Q0 here. This Q0 and Q0, these two values are cancel with each other. Now we get the expression for electric intensity due to the point charge. E is equal to 1 divided by 4 pi epsilon naught. 1 divided by 4 pi epsilon naught Q divided by R square. E is equal to 1 by 4 pi epsilon naught Q divided by R square, which is the expression for electric field at a point due to the point charge in a vacuum or air, or which is the expression for electric field intensity due to a point charge. It is a very simple, it is a very simple concept. ಇದನ್ನ ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಬೇಕು ನೀವು. ಡಿಯರ್ ಸ್ಟೂಡೆಂಟ್ಸ್, ಮೋಸ್ಟ್ ಆಫ್ ದ ಸ್ಟೂಡೆಂಟ್ಸ್ ನೀವು ಹೌದಾ ಕರೆಕ್ಟ್ ಟೈಮಿಗೆ ಯೂಟ್ಯೂಬ್ ವಿಡಿಯೋಗಳನ್ನ ವಾಚ್ ಮಾಡ್ತಾ ಇಲ್ಲ ಹೌದಾ. ಸೆಕೆಂಡ್ ಪಿ ಯು ಸಿ ದಿಸ್ ಈಸ್ ಅ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ಇನ್ ಯುವರ್ ಲೈಫ್. ನೀವು ಕರೆಕ್ಟಾಗಿ ವಿಡಿಯೋಗಳನ್ನ ನೋಡ್ತಾ ಇಲ್ಲ, ನೆಗ್ಲಿಜಿಯನ್ಸಿ ಮಾಡ್ತಾ ಇದ್ದೀರಿ. ಇದು ಯಾವಾಗ ಆಫ್ಲೈನ್ ಕ್ಲಾಸಸ್ಸು ಕೂಡ ನಿಮಗೆ ಸ್ಟಾರ್ಟ್ ಆಗ್ತಾವೆ ಅನ್ನೋದು ಇನ್ನೂ ಕೂಡ ಕ್ಲಾರಿಟಿ ಇಲ್ಲ, ಬಿಕಾಸ್ ಯು ಆರ್ ಬಿಲೋ 18 ಸ್ಟೂಡೆಂಟ್ಸ್. ಅದಕ್ಕೋಸ್ಕರ ನೀವು ಸ್ವಲ್ಪ ಸೀರಿಯಸ್ ಆಗಿ ನಿಮ್ಮ ಲೈಫ್ಗೋಸ್ಕರ ಕರೆಕ್ಟಾಗಿ ವಿಡಿಯೋ ಕ್ಲಾಸ್ಗಳನ್ನ ನೋಡಿರಿ, ಅದನ್ನು ವರ್ಕ್ ಮಾಡಿರಿ. ಓಕೆ, ಥ್ಯಾಂಕ್ ಯು.